Hello, everyone, and welcome to Green, a friend with benefits. I am Baba Safara, your clinical nutritionist in medicine. Today, we are discussing physiological adaptation to different types of exercise. Have you ever wondered why your breathing becomes faster when you exercise? Why your heart beats harder? Or why can athletes perform at levels that seem impossible? The answer lies in physiological adaptation. Our bodies are designed to adjust and adapt to your physical activity. The more consistently you exercise, the more efficiently are your muscles, heart, lungs, and circulatory system become. Today, we'll explore how the body responds to different forms of exercise and how this adaptation improves performance and health. What is physiological adaptation? Physiological adaptation refers to the changes that occur in the body in response to exercise. Exercise places stress on the body. To cope with that stress, the body becomes stronger and more efficient. These adaptations occur in the cardiovascular system, the respiratory system, the muscular system, the endocrine system, and the circulatory system. The type of adaptation depends on exercise, intensity, exercise duration, fitness level, and environmental conditions. The body is consistently adjusting to meet increased demands. How the cardiovascular system responds to exercise? The cardiovascular system includes the heart, blood vessels, blood circulation. During exercise, muscles require more oxygen, more nutrients, and faster waste removal. To meet these needs, the cardiovascular system works harder. The heart pumps more blood. The blood flow is redirected towards working muscles. Blood pressure rises temporarily to improve circulation. These changes help support your physical performance. Understanding cardiac output. Cardiac output refers to the amount of blood the heart pumps every minute. When you exercise, heart rate increases, the heart pumps more forcefully, and more blood reaches the muscles. This allows muscles to receive oxygen and nutrients required for energy production. The fitter a person becomes, the more efficiently the heart performs the task. Why does heart rate increase during exercise? Before exercise even begins, heart rate often increases. This is known as the anticipatory response. Your body prepares itself for movement. During exercise, heart rate increases quickly. Oxygen delivery increases and blood circulation improves. Several factors influencing your heart rate. Exercise intensity. The harder you work, the faster your heart beats. Exercise duration. Longer exercise session increases cardiovascular demands. Fitness level. Well-trained individuals generally have lower heart rate during exercise compared to untrained individuals. Environmental conditions. Heat and humidity place additional stress on the body, causing the heart to work harder. Blood flow redistribution during exercise. One fascinating adaptation is blood redistribution. The body sends more blood to active muscles and less blood to organs that are less active during exercise. Examples include increased blood flow to the muscles, your heart, and your lungs. reduced blood flow to digestive system and kidneys. This explains why exercising immediately after a large meal can cause discomfort, nausea, or vomiting. The body prioritizes movement over digestion. Why hydration is so important? Exercise increases sweating. Sweating causes fluid loss. If dehydration occurs, blood becomes thicker, circulation becomes less efficient, heart workload increases, and performance decreases. Proper hydration helps maintain blood volume, nutrient delivery, temperature regulation, and exercise performance. This is why athletes are encouraged to hydrate before, during, and after the exercise. Blood pressure and exercise. During exercise, blood pressure changes naturally. The heart pumps harder to deliver oxygen-rich blood throughout the body. For healthy individuals, this response is normal and beneficial. After exercise, blood pressure gradually returns to normal. This is one reason cool down exercises are important. A sudden stop after intense exercise may cause dizziness because blood pressure drops rapidly. Cardiovascular response to strength training. Strength training creates a different type of adaptation. Examples include weightlifting, resistance training, and asymmetric exercises. These activities increase muscle strength, muscle size, and force production. During heavy lifting, blood pressure may temporarily rise significantly. For this reason, proper breathing techniques are extremely important during resistance exercise. Cardiovascular response to endurance training. Endurance activities include running, cycling, swimming, and walking. These exercises create long-term adaptation such as stronger heart muscle. The heart becomes more efficient of pumping blood, increased blood formation. New blood vessels develop to improve oxygen delivery. Improved circulation. Blood reaches tissues more efficiently. Better cholesterol levels. Exercise may increase HDL, which is good cholesterol, or reduce LDL, meaning bad cholesterol. Better weight management. Regular endurance exercise help maintain a healthy body weight. How athletes drop an athlete's heart. Long-term endurance during training can cause the heart to grow stronger. This adaptation is often called an athlete's heart. The heart chamber becomes larger and more efficient. As a result, more blood is pumped with each beat. Resting heart rate decreases and exercise performance improves. This is a normal and healthy adaptation in trained athletes. High altitude training. Many elite athletes train at high altitude. At higher elevations, oxygen levels are lower, air pressure decreases, and the body must work harder to obtain oxygen. Initially, exercise feels more difficult. Breathing becomes more faster, heart rate increases, and performance may temporarily decline. How the body adapts to high altitude. With time, the body begins to adjust. Adaptation include increased red blood cells production. Hemoglobin carries oxygen throughout the body. Improved oxygen delivery. That's the body becomes more efficient at transporting oxygen to muscles. These adaptations can improve endurance, performance when athletes return to lower altitude. High altitude and muscle performance. Altitude training can also improve muscle capillary density, oxygen utilization, and endurance capacity. However, prolonged stays at high altitude may lead to weight loss, muscle loss, and increased dehydration. Proper nutrition becomes even more important in this environment. The role of nutrition in exercise adaptation. Exercise adaptation depend heavily on nutrition. Without proper nutrition, recovery and performance suffer. Key nutritional priorities include carbohydrates, protein, healthy fats, water, and vitamins and minerals. Carbohydrates provide energy for exercise. Proteins support muscle repair and hormone production. Healthy fats provide long-term energy and support hormone production. Water is essential for hydration and performance, and vitamins support recovery, energy production, and immune function. Nutrition and exercise work together to improve health and athletic performance. In conclusion, the body is incredibly adaptable. Every time we exercise, our muscle, heart, lungs, and circulatory system respond to the challenge. Over time, with responses come adaptation that improves strength, endurance, circulation, recovery, and overall health. Whether your goal is for better fitness or disease prevention or weight management or athletic performance, understanding physiological adaptation helps you appreciate the amazing possibilities of the human body. Thank you for watching. I am Baba Losefara, your clinical nutritionist in medicine. Please like, subscribe, and share this video to help more people learn about nutrition, exercise, and healthy living. See you in the next episode of Nook Green, a friend with benefits.